Assalamualaikum warahmatullahi wabarakatuh. Okay, so we are group 5. Okay, so for today, we are going to present chapter 6, Aromatic compound. Okay, so let me introduce our group members. First, Farisa Munirah binti Awang Hat, metric number 9211584. Siti Maisarah binti Mohamad Nasir, metric number 9211604. Nurul Haziqah binti Mohamad Zaki, metric number 9211588. Okay, so for class 1, I will pass to the next presenter.
This is the first question, which is by using appropriate equations and stating the type of mechanism involved, explain why benzene is less reactive than cyclohexane towards chlorination. In this question, we need to state the equation and then state the type of mechanism involved and explain why benzene is less reactive than cyclohexane towards chlorination. This is the reactivity of cyclohexane and benzene towards chlorination. So the first one is cyclohexane. We are going to do chlorination on the cyclohexane. When the chlorine added to the cyclohexane, it will produce 1,2-dichlorocyclohexane. So this reaction involves the mechanism which is a free radical substitution. Okay, the next one is benzene. So in this process, we needed Lewis acid such as FeCl3, FeBr3, AlCl3. So in this reaction, we use FeCl3 which is iron chloride. So therefore, the chlorine atom will acting as an electrophile is going to be attached to the benzene and forming an aryl halide, which is chlorobenzene here. For this reaction, the mechanism involved is electrophilic aromatic substitution. And then benzene has delocalized electrons spread over 6 carbon atoms, whereas alkenes have localized electrons above and below the 2 carbon atoms in the double bond. So that's why benzene is less reactive than cyclohexane towards chlorination. Okay.
So here the chemical reaction of benzene. Benzene can further craft accession with ethanol chloride. So here the benzene plus with ethanol chloride, the condition here is catalyzed aluminum chloride. So it will become ethanol. As you can see here, the functional group that attached to the benzene ring is ketone. So and it has one carbon only. So it will be phenethanol. So next, this is reaction mechanism, which is electrophilic substitution. It have 3 steps. The step 1 is formation of electrophile. Step 2, formation of Arrhenian ion. Step 3, loss of proton. It is remove hydrogen. So here the reaction mechanism of phenethanol. But the first one is step 1, formation of electrophile. So here the ethanol chloride. Ethanol chloride EY, E is ethanol and Y is chloride. And plus to catalyze aluminum chloride. As we know, chlorine here is negative, and we know negative will attack to positive, so it will be like this. So it will be E alone here plus with Y catalyst. Y attached to the catalyst, which is aluminum chloride, and it will produce aluminum tetrachloride. Y chlorine will leaving E alone here. It is electrophile. Okay, next step 2, formation of Arrhenian ion. So first, this is chemical structure plus ethanol. So ethanol will attach to the chemical structure. You can see here the double bond, and we know in the double bond it have many electrons. So from double bond, we produce a single bond here when ethanol attached to this, and a positive here. And it also decolorized to this structure, which is double bond can move to other position from this to this, move here to here, and the positive also move the other position, which is here from here to this position, and also decolorized to this structure, which is the double bond here will move to other position, which is here, and also positive sign at the different position, which is from here to here, and lastly it will form the Arrhenian ion. Next, step 3, loss of proton, which is remove hydrogen. So here aluminum chloride, chlorine here attached to H plus will be attached to C here. So it will produce a double bond here. Plus aluminum chloride plus HCl. H here is removed. Okay, this is clarification of acetone. So we can see here, the blue one is the deactivating group, which is at meta position. The green one is the activating group, which is ortho para position, and the red one is activating group, which is ortho para position. So next. Okay, this is reaction equation of phenylethanol react with a hot mixtures of concentrated nitrate and sulfuric acid. This is phenylethanol. Okay, hot mixtures of concentrated nitrate and sulfuric acid. It will produce one product here, which is NO2 at meta position. So why one product is produced at meta position, just one product? Because yes, why just one product is produced? Because the effect of orientation, certitude is depending on the group of the certitude already attached to the ring. Example, auto para director and meta director. Hence, acid chloride are attached to the ring tends to directly common group into meta position. It is because the certitude is the activating group and its position at meta. Certitude, which is NO2, and its position is meta position. So that's all.
This is the last question in class 1, which suggests a synthetic pathway to show the formation of phenylethanamine from benzene. So this is the synthetic pathway to show the formation of phenylethanamine from benzene. So in the step 1, we use Brady-Craft alkylation reaction where alkyl benzene is prepared. We are going to use this Lewis acid as catalyst using the catalyst aluminium trichloride. This is the catalyst. And then when the benzene react with the chlorobutane, it will produce toluene. Step 2, bromometabenzene can be synthesized by the bromination of toluene under conditions suitable for free radical halogenation. Okay, and the last step 3, the bromomethylbenzene reacts with excess of NH3, excess of ammonia, to form benzylamine or phenylethanamine, and this reaction takes place through SN2 mechanism. So that's all for the task 1.
We continue task 2, elect component assessment. So for question 1, choose one type of the mentioned in item N relate to any functional group from chapter 5 and chapter 11. Choose a verse relate to the pen. Okay, so we choose pick. Okay, so from surah 15, A'udzubillahi minasyaitonir rajim, Watin wa zaitun, by the feet and the olive, functional group present is pumpkin. Okay, for question 2, determine and find out any active component present in that plan and then select one component. A, give the organic structure and IP name of the component that you choose. Okay, so we choose 1-methyl-cyclopropene, and this is the organic structure. B, describe the composition of the plant that you choose. Composition include zinc 0.15 mg, sodium 1 mg, carbohydrate 9.2 g, magnesium 17 mg, sugars 6.3 g, fat 0.3 g, and protein 1.8 g. C, give the benefits of the selected component. First, an extract from the leaf of the fig tree conficin can increase insulin and treat diabetes. Second, figs contain many nutrients that are needed so that the body will live longer. Consuming figs is said to help lose weight. Third, figs have vitamin, antioxidant, and minerals that are so excellent for the skin. Consuming this fruit can treat various skin problems such as eczema, vitiligo, and fibrosis. Then the last, canned fruit also has a high fiber content, so it is good for digestion. The high fiber content makes the body absorb a lot of water so that the stool becomes softer. These suggest a chemical reaction operation that can occur with the structure that you have given in A. Write the chemical equation for the reaction preparation, providing the reagent, condition, and study material products of the reaction. So for the chemical reaction, we choose electrophilic addition, hydrohalogenation, Markovnikov rule. So this is a 1-methyl-cyclopropene react with the hydrogen chloride. So the products, okay, this is the product. The double bond will missing, and the hydrogen will attach to the another carbon, and the fluoride will attach to the same carbon with methyl.